Hi everyone, welcome to the next video in the series. This video will demonstrate how to find the derivative of an inverse function. We're going to review some of the concepts that will be really key to understanding this concept, and then discover the process to find the derivative and then solve some problems. So there are some important inverse properties that will be helpful when we learn to take the derivative of an inverse function. And the first thing to remember is that inverses are obtained by switching the x and y coordinate. The domain of one is the range of the other, and vice versa. So this is really important. The second thing that's not as known but also as important is that when you take the composition function of another function, you know it is an inverse when the composition function is x for both f of g of x and g of f of x. This is the algebra, no derivative here at all. Another thing that's important to know is that if you have a point that's on f, say the point 1, 2, then the point on the inverse will switch x and y. So in other words, the x of the function, right, is the y of the inverse. And likewise, the y of the function is the x of the inverse. This is really important that you realize the definition here. So in other words, if I have f of 1 equals 2, then f inverse of 2 is going to equal 1. And that's the notation that goes along with it, and it's function notation, which can often be kind of a mystery to some people. So hopefully not to you. Some other notation, if I take the derivative of f of x, right, it looks like this, the derivative of f of x. Everybody knows that. All right, so, but if I have the inverse notation of x, you can see that taking the derivative or writing that notation gets a little crowded. So f of inverse derivative looks like that. Boy. So a lot of times what they'll do, instead of leaving the inverse notation, is they'll just say f inverse of x. I'm going to call it g of x. I'm just going to call it g of x. So then that way, when I want to find the derivative of the inverse, I'm really just finding g prime of x, even though I know that g prime is f inverse. So that's another concept that's really important to remember. Another concept that's really important to remember is that just as the points, the x and y switch, the slopes are also related. So the derivative of x, if the derivative of x is 2, the derivative of its inverse is going to be its reciprocal. That's it. Okay, so if the function is, the derivative of the function is -1/5, then it's just going to be the reciprocal. No sign change. No sign change. And this is really important that you understand that the slopes are reciprocals of each other. So to recap, number one, these concepts of a function and its inverse is that the x's and y's are switched, or the x of a function is the y of the inverse. Okay? And then number two, that the derivative or the slopes of a function and its inverse are reciprocals of each other. Okay, so I threw this in here because it's table oriented, and I want you to kind of get used to the function notation again. So for instance, here I have this table of a function and two functions really. So in this case, g is just a function, right? So this is f inverse, this is g inverse, and this is just bringing home this concept again that the inverse of a function switches x and y. So in other words, for this one, I would say the y, right, is now the x, and now the x is now the y in an inverse function. All right, so here this would be 1 and -2, and then you would flip it around. So -2 and 1. All right, so over here, where we're talking about finding the value of g inverse of f inverse of 2, right? So I'm going to start with the inside function first, and the inverse function of 2, right, is this one. Or in other words, the y value here, then this is going to be 1. So then G inverse of 1, right? So I'm going to come over here. G inverse of 1 is this one. So this would be negative 2. And if I look at it here, it's the y. All right, and so that one is going to be negative 2. Now to find this value, right, I'm going to find G inverse of negative 2. Well, G inverse of negative 2 is 1. Now what does that look like on this one over here? Well, G inverse of negative 2 is a y value. So this is just 1. So what's f of 1? Well, that's over here. F of 1 is 2. So here's how they derive the formula to find the derivative of the inverse, right? So we're going to start with a composition function of f and f inverse, and then we're going to take the derivative of both sides. So this side over here is a composition function. So derivative of the outside, this is chain rule, right? Derivative of the outside, inside stays the same, times the derivative of the inside. So I'm using that awkward notation, derivative, okay, equals, the derivative of x is just 1. Okay, now we found that before, that was that composition function. Well, this part right here is what I want to find the derivative of. So I'm going to solve for it. So that's going to be that the derivative of the inverse, this is really unwieldy, plus my jot keeps doing weird things, I'm sorry about that, equals 1 over, and then I'm just going to put this on the other side. So f prime of the inverse of x. Okay, and that is the formula. So when you talk about this, right, when you talk about it, what we know that this is 1 over the derivative of the function, 1 over the derivative of the function. So in order to find this, we can take the derivative of f, right, and then plug in f inverse of x, okay, and then take the reciprocal. So what is f inverse of x? Well, this is a y value. So the y value of the inverse is the x value of the function. So this is the y value You see how this gets a little confusing, x and y switch. So let's see what this looks like in a problem. So in this problem, it gives us that f of x is equal to 3x plus 2. The derivative of f at negative 2 is 3. What is the value of f inverse of negative 4 and the derivative? So what's the derivative of the inverse at negative 4? All right, so the first thing to understand about this is what is f prime of negative 4? Well, the x of the inverse is the y value of the function, okay? And so I need to know what the x value of the function is. So I'm going to set f of x, here's f of x, is equal to 3x plus 2. I'm going to set that equal to negative 4. So 3x equals negative 6 and x equals negative 2. So that's the x coordinate, right? So negative 2, negative 4. The inverse, right, is going to be negative 4, negative 2. That's the inverse. Okay, so I need to find the derivative of f, which is 3. And then if it had an x in it, I would plug in negative 2. But what is the derivative of the function? Well, it's 3. So what's the inverse? What's the derivative of the inverse? Well, how are they related? They're related because they are reciprocals. So this is 1/3. Now in this example, we're asked to find g of x, g of x, the derivative of g of x. Well, g of x is the inverse of the function. So instead of that unwieldy notation, we're just going to call the inverse g. All right, so they tell us that f of x is this function, and g of 1 equals 0. Well, friends, if g of 1 equals 0, then f of 0 is going to equal 1. Yes? All right, so let's take the derivative of f, since we've got it right here and we can do it. It's going to be 3 minus cosine x, and then I'm going to plug in the y value of the g function, okay? Because that's the x value of f. So this is going to be 3 minus cosine of 0. Cosine of 0 is 1, so 3 minus 1 is 2. And g prime of x is 1 over f prime of 0. So this is going to be equal to 1/2. So in this final example, g of x is declared to be the inverse of f of x to simplify the notation. I want you to find g of a and then g prime of a. So the inverse at a and the derivative at a. And so then they give us a function. This is the square root of 2x minus 3, and it is all the way across. This is all the way across. So, and then a is equal to 5. So what we want to find is we want to find g of 5, which is a y value, right, of the inverse. And then we want to find g prime of 5, which is the derivative of the inverse. Okay? So if we know that g of 5, if we know 5 is the x-coordinate of the inverse, right? If 5 is the x-coordinate, that's where it is, of the inverse, it's the y-coordinate of f. Okay, so I'm going to set f square root of 2x minus 3 equal to 5. And then I'm going to square both sides. So that's going to give me 2x minus 3 equals 25. 2x equals 28. And x equals 14. All right, so the x-coordinate of f is the y-coordinate of the inverse. And so that's 14. That's what you're finding. Now I want to take the derivative of f. So f prime of x is equal to 1/2 2x minus 3 to the negative 1/2 times the derivative of the inside, which is 2. 2 over 1/2 is just 1. So this is going to be 1 over the square root of 2x minus 3. Now, what did I find x to be? Well, I found x to be 14. So f prime of 14 is 1 over the square root of 28 minus 3, which is 25, right? So 1/5. Right? That's the derivative at 14. So what's the derivative of the inverse? Well, they're reciprocals of each other. So it's 5. So there's a lot here, but this is meant to help you make a little more sense of finding the derivative of the inverse function. There's usually at least one or two, and usually in table form on the AP exam. So, and of course, it will also be on the next unit exam, which is coming up. So please look through this and bring any questions that you have back to class. See you then.